let's begin. So I'd like to welcome our final speaker for this part of the afternoon. We continue after the large coffee break. And our next speaker is Marina Krotofil. She's an experienced pen tester, researcher on industrial control systems. And she's been specializing in reverse engineering security analysis of PLCs, exploiting software architecture design, is what it says here. And she's going to talk to us about hacking PLCs, how current PLC designs are inherently vulnerable, and walk us through a threat scenario and hopefully some mitigation as well. Or is it just doom and gloom?
Not
Please?
included.
Okay. Over to you. Thanks.
Thank you for adding me extra skill on the reverse engineering. I'm really poor. I'm terrible on that. I can do the bare minimum. So this is a really completely brand new talk. So we actually completed the research last year, and it was accepted for Black Hat USA 2020. But because myself and my co-researchers, we've changed jobs, we've been in a position where it would not be appropriate to speak about like exploitation techniques. So we actually have to withdraw. And this is really like, we've just like really dug down this research just really a couple of weeks ago. So yeah, I probably won't be even very fluent in talking about, because it's just like really, like I put like slides together not a long time ago, so it's just really brand new. So I have a little bit of introduction about, but like something what we've been already talking, Trey have given like fantastic introduction, but it's just like kind of builds my storyline, is that, you know, like supply chain, of course, nothing new, and you probably have seen these pictures, how like NSA is intercepting, you know, like shipping and, you know, like replacing it with something that has already something in it. You know, like one of my friends who purchased basically a new external sound card, he received it and analyzed it, and it was infected. And he received it from the Amazon. He ordered it on the Amazon, and it was infected already with exploit, which actually he himself developed. So just like, was terrible. But, you know, like, so, I mean, these things happen. And so it's basically this famous, you know, Trojan situation. And the most devastated supply chain attack to date is, of course, was NotPetya. And the reason also why I'm talking about it, I'm born Ukrainian. So clearly, so not only that, I've been also part of the investigations, conversations with the government and so on. I've been for several years, I've been doing a lot of incident response in that in my country, or assisting a lot of local organizations and so on. And it's really fascinating how in less than 24 hours, you can completely put on the knees the functionality of the whole country. So in less than 24 hours, they pushed the update, they infected the machines, it propagated, ransomware, everything, and basically the entire country, the entire functionality was put into halt. You could not do anything. You cannot purchase groceries, you cannot withdraw money, you cannot use public transportation, you cannot use medical services, you can't even find needed medication in terms of emergency. So it was really meant like as a military operation, and this is how it was executed. And this is why also, you know, the insurance companies refused to pay insurance because they classified it as an act of war. So like supply chain attack like can be really very powerful and devastating. So since then, of course, complexity of impacts and impact of those attacks has grew. And, you know, like I was kind of the opinion that they mostly like of the level of the state sponsor, because not only that you need to compromise the supply chain, but you also need to monitor what are you doing with it, who is infected, how do you go after them, how do you get back to these machines which you previously infected. But apparently, according to Trave, that we actually also the cyber criminals are capable of such level of exploitation. And it's just like few examples of what was happening. Actually, this one is infected printers in Ukraine. which were talking directly to the C2. And actually, there have been also situations when the police stopped a truck, and they've been in the truck. They've been sitting, which was shipping actually printers, also printers, and they've been sitting people inside of the truck, and they've been opening boxes and infecting the printers, or basically replacing, I don't remember the details, or replacing the printers with infected with the bugs, which will be then speaking like directly communicating to C2. And all of this. And, so supply chain really was recognized this year, really key problem that even at Black Hat USA, the keynote was dedicated to supply chain. So when we talk about supply chain security, there are two parts to it. One, it is that we are using the supply chain as attack delivery vector. So for example, as also Wendy mentioned in the morning, that certain equipment of certain vendors we are not even using because we don't trust it anymore. But it also, sometimes threat actors use trusted communication links from for example, subcontractors to get access to the organization of interest. And if you've been following this hack from the Wipro in 2019, it was really funny that the customers of Wipro has reported to Wipro, hey, you're infected because we already, people coming from you to us, do something about yourself. And the other part is that when we talk about supply chain security, we're talking about what is the attack surface of the assets which we are purchasing. So for example, very often, and this is one of my favorites, when, for example, those security devices or appliances which are supposed to protect us, they're supposed to protect. And they are, for example, very often the Kerberos or LDAP protocols are not correctly implemented on the assets, and basically it's allow the authenticated takeover of these security appliances. So when purchasing such appliances, you hope that the vendor has done due diligence, but not always. And this is actually will be the focus of this talk. And this is where, of course, the software bill of materials comes handy, because then you can know what is inside, which libraries, and so on. So all the topics which we discussed. So clearly supply chain security. So I'm working in the area of critical infrastructure security, which the abbreviation is CI, or you probably have heard it as OT, operational technology, or ICS, industrial control system security. And clearly it is understood that security of the assets, be it applications or hardware, is very important. And in the OT space, everything around the globe, everything is governed by the IEC 62443 standard, and it target at three parts: at vendor, integrator, and asset owner. So vendor requirements to the vendor, how they produce the equipment, is a big part of this standard. So for those who are not really super experienced with OT, this is examples, for example, how the industrial controllers could look like, depending on which area you're deploying them. And they, of course, the problem with them, they don't look like normal computers. They are embedded systems which run firmware. And when we talk about when you as an asset owner trying to procure these assets from the vendor, you're deciding of which security level your device should be. And security level is dependent, it's everything from the standard. So you have some foundational requirements, which could be of 4 different levels. As you can see, which one side? It's, my goodness, the green table. And as you can see, it's quite arbitrary, because security level 1 is script kiddie, security level state sponsor. What exactly state sponsor should be capable of, what script kiddie should be capable of, there is no really explanations. It's a little bit arbitrary. But basically, this is specifies, if you, for example, if you're purchasing an equipment, you are telling, give me a piece of equipment which, for example, is robust to security against the threat actors of level 4. And in order to ensure that the device is meeting that security requirements, there is a certification, of course. We cannot live without certifications. And if you could see here is what certification is claimed, is that asset owners, that it's supposed to claim, to provide that asset owners have confidence that the products they purchase are robust against network attacks and free from known security vulnerabilities. That's a gigantic claim, as you can imagine. And this is, for example, at the bottom you have a took a snapshot, for example, 2 Honeywell controllers which are certified for level 1 and level 2. Level 1 is a script kiddie, big achievement. And the point is that you see, like this is like, again, this is how the certification is done. It's tested a little bit for like a couple of weeks, and for a complex piece of equipment, it's nothing you can imagine. So, and it is mostly, it's about functional security testing. Like, do you have authentication? Yes or no? Is a password longer than 8 characters? Yes, it does. Great. Do you require special characters? Fantastic. Test passed. Strong authentication. So it's mostly about finding this very, very low-hanging fruits. So it's definitely not testing about like known vulnerabilities. So it's kind of, there is a claim that you will be of level 4 against 10% attack, but we are never so. It's just like really just a paper. So, and this is what, for example, like for level 4, we'll have for network-based attacks. There will be like 2 weeks of testing, like, oh my God, so much testing. And like in the past several years, there have been like literally several companies been reporting in bulks, like really very severe vulnerabilities in the communication stacks used in this type of equipment, which literally was put into panic mode, governments around the world and asset owners around the world. One of the key topics which I especially enjoy and frustrates me really very much is authentication in these controllers. And in this specific case, I just pick a couple of examples for Siemens. In reality, there is more papers. It's just like, you know, like I had only this amount of space on my slide. And even though like all of these controls are certified, they're strong, blah, blah, but the point is that, yes, there is authentication scheme, but all of those authentication schemes are broken. And typically this, you know, like basically they are broken by whom? I didn't want to try to offend the researchers that they're not very advanced, but this is a master level. You know, it's just like university, it's your master arbeit. It's not state-sponsored attacker. So you see, like if it is authentication, which is done like breakable by a student, you know, like we can't really call it, do you have authentication? Probably not. So, and this is a point that you see, like when we purchase these devices, we really do not understand what is the attack surface for these devices. And this is the other side of the coin of the supply chain. So why I'm interested in this topic is my research specialization is offensive cyber-physical security and critical infrastructure. So basically what I'm doing, I'm specializing in physical damage, or how do we degrade or sabotage physical infrastructure, starting from production processes, piece of equipment, or anything you think. I take physical objects, design first, engineer, damage scenario, and then I work backwards to understand which exploits I need to develop, in which assets, and so on. So, and overall, I'm considering the whole cyber-physical attack lifecycle, which you see at the bottom, which is developed by me. And because I'm pretty much, there is not very many people in the world specializing in this strange area like physical damage, so I'm probably one of also few people who only uses this attack lifecycle. But in general, as a normal attack lifecycle, in cyber-physical domain, we also go through stages. And there is a lot of activities the attacker needs to do before being able to develop a workable exploit. And when we talk about the basically design of the equipment, I'm thinking from, when I look at the such devices, I look from 2 perspectives. One is like, I'm trying to find the, let's say, vulnerabilities or flaws which would allow the assist with attack activities, for example, with reconnaissance, or exploit this asset design for the attack execution. So, and I've been publishing and speaking like academic papers and also speaking around on the stages a lot about that. And one of the topics which is kind of still there is very little public research is so-called process comprehension. So it's basically what we call reconnaissance. So in the IT, it's a very well understood process. We also have a lot of tools. In the OT, there is very few, there is almost no public tools. And there is also very limited understanding what it encompasses. What do we need to do to achieve a desired process comprehension, like configuration of the control infrastructure and how the process is programmed to function. So typically it's a lot, depending on what your attacker goal, it's really a lot of manual collection of the information and processing of really diverse information. So it's basically, it's all of from my pieces of work. But the key component, of course, for exploiting an industrial process is control logic. So it's basically the code which controls the physical process. And it comes in different forms and shapes. It could be written in different languages. And one of the famous languages is probably most people know is so-called ladder logics. This is what you see, and this is one from my doctoral thesis here. So, and this gray boxes which you see, this is a normal so-called standard functions. So if you program, you know that you have functions. Only that when we use those function blocks in the ladder logic, we do not reference to them, but each time when you need it, you have to use it. So it's basically like, see it as a more like well-tested piece of code which you keep copy-pasting in your code. So, and PLC vendors, they offer like libraries of standard function blocks. So you can see here is like Modbus communication function block, and all of them, so you can see various variables which comes in, goes out, and those value of those variables, they're stored in so-called data blocks. So sometimes you can see here also the words variable block. And all of those values stored in the memory, and as you can see, they have offsets. Well, yes, so what I wanted to show, this is not a screenshot from our lab. I could not get access to the lab. I grabbed it from the internet, but this is how the programming interface would look like. And what I outlined it in red, it's libraries. Unfortunately, I could not find the picture on the internet with libraries, but it will look something like that. So, and the way how Siemens PLC allocates the memory for these addresses, not only that it is always at static addresses, so it will be always in the same places, but it also, for every variable, as you can see, it allocates 2 bytes. Sometimes it's 4 bytes, but in most cases it's 2 bytes. It doesn't matter, maybe, for example, if it is a Boolean, you only need 1 bit. You would still always allocate 2 bytes, and the rest of the memory will be simply unused. So, basically, that pattern of unused memory is actually unique for every function block. And actually, so if you know what rainbow tables are, so you basically, because the library of the standard functions, it's known. If you have a TIA Portal software, you know all of those functions. So you actually, if you are able to basically enumerate this empty space in the PLC memory, you actually can enumerate all the function blocks used in that controller in control logic. And this is what we used basically to enumerate function blocks. So why it is significant? So in the past, we actually believed that basically interrogating control logic in the PLC is like there is no ways to do so. You would need to get either like compiled code and then decompiled. It's so difficult, it's almost impossible. So finding the automated way to actually enumerate which function blocks are used on the PLC has never been done before. And we really were actually surprised. So we've been looking at that memory for a very long time until we just like, what can we do with it? And it was literally almost like this COVID situation, with just like let's play around it. And then it became like, my goodness, this is really offers you such a significant, I need to be careful with time, attack vector. So I need to speed up now. So how do we do that? So the point is there are multiple ways how you can interrogate a PLC to know which function blocks are used in the control logic. But the point is that you want to have stealthy. So for example, there are standard functions, for example, get block info, which you can see at the top, here, which allows you, like basically by knowing, like for example, here's family, header, blah, blah, it allows you to kind of give you hints what kind of function blocks it is. There is a bulk transfer, this is our own terminology, how we called it, which is when you use a command block upload, basically upload the PLC is given me, it's uploading to me, which is basically as a byte code. And if you implement a relatively simple parser, you can still parse all the information which is present in here. The problem with these two ways of like querying this information is that this is a rare command, and if you do network monitoring, they are detectable. So, and this is all network API, how user can interact with the PLC. So there is another way, is like, there is a standard command which is read, which is a legitimate command because you can read from the, for example, like HMI, human machine interface, and databases, they continuously read data from the PLC. So it's a normal command. You can actually what you do, you start basically reading from the beginning of this location of this data block, and you read byte by byte. And you basically interrogate the whole memory. And then not only that you can know what is the size of this library, which again can, if you have already the rainbow tables, if you have like, I don't know, 390 bytes, it's probably like this library. But also basically by mapping this empty space, you can actually know which function blocks is used. So in that way, you actually can enumerate all function blocks used in this in the PLC. So it's basically like kind of information leakage vulnerability. So what we can enumerate, it's literally hundreds of standard function blocks, communications, remote administration, control algorithms, safety functions, like literally like lots. And we did not really look into like trying to understand each of them, like what delicious can we found them, because you see like it really requires a lot of engineering knowledge. So the closest analogy previously seen in the wild was a Havex attack. I don't know if anybody have heard about that, but it was of course coming from bears from Russia when they've been executing a really very complex reconnaissance attack on industrial infrastructure where they've been trying to enumerate industrial equipment. So once we enumerated all the function blocks in the PLC, we can actually start exfiltrate their content. We want to know what are those variables, which are the values of those variables. And again, we do that with a standard read request, which is a legitimate command. And the location of each variable within data block is known. You know where the data block, how to address the data block, like number 1 or number 2. You know the offset, and then you know that, for example, need to read 32 bytes. It's very easy. So large variables, like, for example, like passwords or emails, they are stored in a separate database, and they are addressable by pointers. So you just need to first to go to the, for example, in this specific case, it's here. You need first go to this offset, exfiltrate the memory location. Then you need to decode it. It is basically stored in a specific format. You need to decode it, which is not very hard. And then you go to the local global database, and then you exfiltrate either email where you send your alerting information, and you can also exfiltrate the passwords of the emails and so on. So sometimes they send alert by the phone numbers and so on. So you can exfiltrate all of the juicy information. Everything is stored in the clear text. And then, of course, you can start with most interesting part, of course, content manipulation. So you can basically, again, modify the value of any variables of your choice. And again, because it's all standardized libraries, which you can learn, you can study. You can do this everything in automated ways. There is no need of human presence. There is no engineer need to be in the picture. You write an automated malware which can enumerate, exfiltrate information, and then rewrite it. So there are, of course, not without the caveats, and again, I have to be quick. There is not without the caveats. There are interesting, of course, edge cases. There are certain race conditions which are absolutely overcomable. There are smart tricks which you can use. For example, if you cannot manipulate one variable in the function block, you can still find the way to manipulate it in other ways. So it's all, like, let's say, overcomable. Then what else we use this unused memory is to establish the covert channel, C2 channel. And the picture which you see here, like, disregard the red arrows for the moment, but this will be the standard architecture of how you would deploy equipment, for example, like for remote water monitoring, like basically water in the water utility. So you have local substation with equipment, you have data center which contains your SCADA server, like your control applications, and you have remote location with alarm management. The point is, again, I have to be a little bit faster, that this is the standard architecture with the best practices as how you should segment your part of the network according to the IEC 62443. And so if the attacker, for example, will compromise the SCADA server and also manage to compromise the HMI in the substation, so if the attacker would compromise the C2 server, he only will be able to communicate with the RTU in the substation, but he does not have access to actually manipulate the PLC, and this is what would be interesting. So if the attacker managed to compromise both HMI and the and the SCADA server, and those cases, again, there are lots of cases where the attack both able to compromise all the needed infrastructure. By using this read and write request, they can actually speak first to so they speak through the SCADA server to the PLC, and basically they relay the command, like for example, ping or anything, like basically any command which you want to execute at the level of the command console. The commands are relayed to the HMI, and then from the HMI you can basically enumerate the whole infrastructure. And this will be undetectable because you're using the permissible command from the permissible servers. So we've done like very extensive testing of the industrial firewalls, which typically using these architectures. And of course, for example, so if such a command are issued from the untrusted devices, for example, if the attacker has compromised this architecture, like this environment somewhere from the internet, from the attack infrastructure, obviously it is detectable because it's untrusted IP address. And if it is from the trusted devices, you're using read and write commands, then all of these attacks goes undetectable. We also tested, like for example, in that case, we have access to Clarity. This is a network monitoring solution which actually creates a baseline of your traffic. And clearly, we create a little bit more of read and write requests than usually. So they obviously see that, well, it's starting a little bit to deviate from the baseline. And but in this case, they do not generate a security alert, but they just generate an event like baseline deviation change, not a risky change. So this will not be even forwarded to the SOC if you have one. So that's actually like all of these techniques are completely stealthy, even if you use like modern security monitoring appliances in your infrastructure. So we also tested this for the other types of equipment, for example, like whether this attack vector is applicable for other vendors, and they do, because they also apply similar memory allocation strategies. And the conclusion is that by exploiting this again, so we would think that we reported this to Siemens, and of course Siemens says like, well, bad luck, applied by security practices, not big problem. They did not even issue an advisory that you should be aware of this. So we discovered this gigantic attack surface, which allows you a high precision automated attack on critical infrastructures, and they did not even issue advisory to the customers. And this is really undetectable by the recommended security appliances. So, and it is again, so the beauty of this is fully automated, something that has never been possible before, and it is high precision attacks, again, so in a fully automated way. And so last sentence is that, of course, sometimes, because the memory allocation is still done in the same way. So many companies are developed custom function blocks if they do something weird like robotics or whatnot. But typically this PLC code is done by the subcontractors. So you can infiltrate subcontractors. So you basically do attack on supply chain. You exfiltrate the function blocks from the subcontractors, do the mapping, create your NBO table, and then you can go to the target environment and still enumerate all of the function blocks on the PLCs and do targeted manipulation. Yes, and basically, so maybe the last is that at the moment, if anything has happened, if any incident is happening in any environment, that's typically the asset owner is to blame. They carry all the responsibilities. And I really think that we should start sharing it with the asset vendor. So that was it. And actually, I woke up this morning and I forgot that I had my birthday today.
Oh, thank you and congratulations. Grief counseling will be available later outside. Good Lord. Are there any questions for Marina? And thank you for this tour de force of the attack surface. What can we do to mitigate this?
Yeah, we've been outlining a lot. So there have been, gosh, to be honest, I forgot the full list of things which we can do. Of course, we should stop using, even the simplest, don't leave this, basically unmapped memory, fill it in with rubbish, canaries, stack canaries, even simplistic things would help a lot. You could also, like this read write, use some protections, like authentication on them. I forgot there have been like, you could, to be honest, I forgot in this, it's been a while since I look into our research. They've been like in the new version of the PLCs, they've been trying to introduce some protections, but they've done it so poorly and without consideration that I forgot the details. I really need to look it down, but it was like almost like it's a nice attempt, but does not work.
Is it inherent in the programming languages that are being used?
No, it is inherent in the people brains that they need to start.
Okay.
You see, the problem is, like, I've been teaching at the university. We teach software, like, let's say, security as a fundamental, science, like what are like cryptographic primitive, what is authentication, what is the signature. The problem is we do not teach how to design, like, for example, authentication scheme, how to design software, how to design anything. And this is where things go wrong. So this is a practical skill which we do not teach. And typically, because you see, like, especially in the area of industrial controllers, it's typically engineers who program them, engineers who develop passion for programming, they start programming PLCs. And those not people who, like, typically normally, like, each decision which you make, you need to do like the secure development lifecycle. You need to evaluate what is the attack surface, what is the exploitability. Yes. Nobody got time for that.
Well, also the attacker model.
Attacker model, and again, those authentication schemes which I was been showing for the Siemens PLCs, one of them is simply by observing traffic on the wire. You don't even need to reverse engineer anything. By simply observing traffic on the wire, you are able to break the whole authentication scheme. This is really, really very poor design.
Also the attacker model that you showed us, there's one component that is kind of not shown. That's the intent of the attacker. A script kiddie will not care who he attacks, but a state-sponsored attacker, which we see in the PLC, will care, and they will be funded and successful.
Yes, and this is why we also a little bit hesitated to publish this, because it's really informing, of course, like typically if my slides are not available immediately, we receive like emails like publish it immediately, we need to update our knowledge. So because this is a skills, of course, which are, this will be used somewhere.
But is it even updatable? We have investment goods with a depreciation of decades.
No, yes, this is not updatable, and even like the oldest versions of the PLC will be first produced by Siemens till 2023, and then 10 years supportable.
Right, fantastic. Are there any more questions? You all look very, totally undepressed. Okay, thanks again. We have our customary, totally personalized speaker gift. Thank you very much for that interesting talk. And I'm sure there'll be lots of questions in the break.